This is never a sound you want to hear when trying to crank your engine. About 2 months ago, it started taking longer and longer to start one of my HPDI engines. And it would sound like the engine was just struggling to start. It sounded like a weak battery. So when I'd get home, I would charge my battery, everything would look okay, and then it would be difficult to crank again the next time I went out. It kept getting worse to the point where I would have to put the battery selector switch to all to put both batteries in parallel just to get the engine to start. Then it got to the point where it just wouldn't crank at all. In this video, I'm going to go through the steps I took to troubleshoot the problem, how I resolved the issue, and it was not the battery. By the end of this video, you'll be able to tell if it's a battery, a starter, a connection, or a problem like I have here. Before we go too far, you're going to need a DVM. It's a digital voltmeter or a digital multimeter. You're going to need a meter that has the min-max feature, and you can tell it'll have a min-max button on it, and you can see it here circled in red. The meter I use in this video is a Fluke 87. I've had this meter for over 25 years. I've dropped it a lot, used it a lot. It's a very robust meter, but it's expensive. So you can see here, I looked at the price now. It looks like it's around $450. Alternative, which is still good meters and will last you a long time, is the Fluke 114 or 115 or 117. If you really want to go cheap, I see on Amazon there's a meter. It's the Astro AI DM6000 that has a min-max button on it. It's around $30 right now. I don't know anything about it. I don't know how well it works, but it's a cheap option if you want to try. But I'd suggest going with one of the Flukes. They'll last you a lot longer, and I know you're going to get a good performance out of it. If you've had a boat for any period of time, then you know a good majority of your problems are actually electrical problems, more so than mechanical problems. So having a good DVM available is I consider a necessity for any boat owner. Now let's get into it. First, I get the muffs on because I don't want to damage the water pump impeller. I use a hose splitter up at the side of the boat with shutoffs so I can turn the water on and off from the boat so I don't have to leave it on for a long time. I'm in California and we don't have any water. I'm double checking that I turned the water on for the right motor. There's the bad sound. The engine's not turning over. Here I'm replacing the standard set of test leads that come with the meter with a set of alligator clip leads. They usually don't come with a DVM, so you'll have to purchase it separately, but they're not too expensive. I set the meter to the DC voltage measurement setting. It's the V with the solid and dash line above it. Now I'm hooking the alligator clips to the battery. And I get a good voltage reading. Now I'm pressing the min-max button on the DVM. I'm doing this to put it in a mode where it checks the minimum and maximum ranges of voltages as I crank the motor. You see that I got it in the correct mode because it says recording up at the top of the display. After I cut the water on, I crank the engine, and now we can see how low the voltage drops. I press the min-max button to cycle through the ranges. I get the max, I get the min, and I get the average. The minimum number is the number we're interested in. 11.8 volts is my minimum voltage. If you do a Google search on minimum starting voltage, you'll see a lot of different numbers. Generally, I'm saying 11.8 is going to be fine. If you're above 11.8, you're okay. There's lower numbers that are there, and later I'll talk about this more. Actually, I can start this engine with a lower voltage. But really, the starter is going to make the biggest difference, and then how much torque it's going to take to turn the engine is going to play a factor. But I'm just going to say 11.8 is good, so this is good. Now that I'm satisfied the battery is okay, I'm going to pull the cowling and measure the voltage at the starter. I need to pull the flywheel cover off so I have easier access to the negative or return connection. The flywheel cover on my engine just lifts straight up. It's held in place by grommets. I'm just moving the flywheel back and forth a little to see if there's any binding or excessive torque. In this case, there is none. Another place to check for binding or excessive torque is the starter. It should turn relatively easy. So the starter has a large wire going to it. Pretty much all motors are going to have this going to the starter. That's your main battery cable. It's going there, so you want to click your red lead onto that. And this Yamaha doesn't. I believe most starters aren't going to have a dedicated return wire. It's just returned on the block. You can just follow the big black battery cable to the position on the motor and connect there. I cut my meter back on and I press the min max button to set it back up to reading the minimum and maximum ranges. Now I go through, turning the water on, starting the engine so I can get my voltage drop or my minimum voltage. And you can see here, I don't even have to go back and press the min max, but I will to see what the minimum voltage is. But you can see it dropping to 3 volts, which is not good. So it had dropped to 1.56 volts, which is really low, and that tells me that I've got a major voltage drop across the cable. 2 things that will cause this. One is there's something wrong with the cable. It could be damaged. There could be corrosion at the crimp sites. The lugs could be loose. And you need to check all that. Or it's just pulling too much current. That's less likely if you're not feeling any torque when you're checking things. And you're not seeing your battery voltage drop too low, then it's likely a problem with the cable, with the main battery cable going from the battery to the engine. And you'll see that that's my problem here. So now I'm going to disconnect the battery cable from the battery in the engine and just check its resistance. With the DVM, I use a 9/16 wrench. Get it off the battery. That can be different depending on the type of battery you have. And I'm using a 12mm socket to get the battery cables off the engine starter. And the return cable off the block. Now I'm going to measure the resistance across the cable with the DVM. I'm going to hook one lead to the negative terminal that I've disconnected from the battery, and I am going to get the negative lead on the battery side and measure it as well. You need to make sure you disconnect your cables from everything. If you leave it hooked to the battery, there are other cables running from the battery coming back, and that's going to give you a bad reading. You're actually going to be reading the resistance of this cable. If you leave it connected, you're going to be measuring the resistance of your battery cable along with other control cables that are connected to the engine that has a return path. So you need to disconnect. Also, never measure resistance when you've got it voltage hooked up to it. That's going to mess up your resistance readings as well. And that's why we're disconnected from the battery. So everything's disconnected here. So we're sure we're only measuring the resistance of one cable and not getting bad readings from any current flowing through that cable besides what's being applied by the DVM. One step I don't show here, you should just measure your leads, connect your DVM leads together and see what your resistance is with nothing, just lead to lead. It should be 0.1 ohms or something small like that. Here in this case, I'm measuring across the negative side of the cable. I'm getting 158 kilo ohms. That's way too high. It should be down less than an ohm. Now I'm going to measure the other leg of the cable, the positive side or red cable. I'm getting 0.6 ohms, which is expected, and you should see that or lower. But like I said, if you see anything over an ohm, you've probably got a problem. Even though I've already found my problem, I'm going to do one last check. I'm just going to check the resistance across the starter to make sure there's no issues there, and I'll show you what the at least the resistance should be on the starter on my Yamaha here. I'm getting almost 3 mega ohms. Here is a simple schematic diagram to make it a little more visible of what's going on. You have a battery, you have your engine block, you have a starter, there's your flywheel, and you have your ignition switch. These are the big heavy battery cables that run from your battery to your engine, and you'll have a bundle of cables that will run up to the front where your controls are, and it includes your ignition switch. You'll have power going straight to your starter or to a distribution block somewhere where it'll go to your starter and all the other electronics, and your heavy negative cable will generally go to the block, the engine block, or it could have another distribution. On the Yamaha, my Yamaha, it went to the block. This little box here is where the fuses and relays, other electronics is broken out from there. It's just a little distribution area. But in simple terms, you have power that goes to your starter, and you have your return that goes to your starter. But your starter doesn't turn on because there's a solenoid in here that will make contact to hook your positive lead of your battery to the motor to turn the starter. So when you turn this key switch, you get current flow through here that turns on the solenoid that pulls down a contact that then turns your starter. The problem I'm having is if you have a lot of current that'll go through here to turn this motor. And if you have a bad spot in your wire where you have higher resistance, when you start flowing a lot of current through here, you're going to get a voltage drop in that area. You're not going to get the power that you need to get the starter to turn like it's supposed to. I'm going to end the video here, but I'm going to make another one showing how I got the battery cable out and the damage and got everything hooked back up and working like it's supposed to. If this video was helpful to you, give me a thumbs up or subscribe or leave a comment if you've got any questions. Thanks.